Welcome back mga kasemento!
For today's video, we will be conducting a test on hardened concrete, specifically the rebound hammer test or the ASTM C805.
The rebound hammer test, also called a Schmidt hammer, is a non-destructive testing method of hardened concrete which provides a convenient and rapid indication of the compressive strength of concrete.
Rebound hammer test is applicable to assess the in-place uniformity of concrete to delineate regions in a structure of poor quality or deteriorated concrete and to estimate the in-place strength development.
So now, let's go to our test area.
To proceed with this test, we will need the following apparatus: rebound hammer, medium grain texture sandpaper, chalk, and ruler. First, we must find a concrete surface that is at least 100 mm or 4 inch thick and fixed within a structure with no honeycombing, scaling, or high porosity, like this surface located in room D4 at the School of Engineering Technology building in Mindanao State University, Iligan Institute of Technology. The test area shall be at least 150 mm or 6 inches in diameter, and if the surface is heavily textured, it must be sanded with a medium grain texture sandpaper. But if it already smooth, there is no need to sand the surface. Next, we will put markings on the surface by drawing a minimum of 2x5 grid. For this test, we will draw a 5x6 grid. The purpose of this grid is to locate our target points so that we will uniformly test regions as possible and to avoid repeating the test on the same point. After preparing the surface, we will now set up our rebound hammer ready for test.
To start, turn on the instrument and hold it firmly so that the plunger is perpendicular to the test surface. Gradually push the instrument toward the test surface until the hammer impacts. After the impact, maintain pressure on the instrument and if necessary, depress the button on the side of the instrument to lock the plunger in its retracted position. Read the rebound number on the screen to the nearest whole number and record the rebound number. Take 10 readings from the test area. No two impact tests shall be closer together than 25 mm or 1 inch. Examine the impression made on the surface after impact, and if the impact crushes or breaks through a near-surface air void, disregard the reading and take another reading.
Based on our test, we gathered the following data. For the calculations, we consider the nearest whole number of the data and also consider the nearest whole number of the average. Using the whole number of the average, we compute for the upper and lower limits by adding 6 and subtracting 6 respectively from the average. Discard any reading that goes beyond the limits. Based on our computation, no data will be discarded. For this test, the average rebound number to the nearest whole number is 9. The standard specification is as follows. Since the rebound number 9 is less than 20, this indicates that the hardened concrete of the test area is of poor quality. Therefore, the hardened concrete of the test area failed the rebound hammer test given its specification. Possible reasons for this may be due to the old age of the concrete resulting to a weak compressive strength and may be worn out due to heavy traffic. Possible recommendations may be to replace the concrete with better concrete mix design which can support heavy traffic, or reinforce the concrete with stronger materials such as steel bars.
And that's how you conduct a non-destructive test on hardened concrete using a rebound hammer.
And we hope you learned something from this video. Stay tuned for our future videos. See you soon mga kasemento!